Continuing on with example 1, we had just looked at the probability that a bolt we chose at random was greater than 15 centimeters long, and we figured out that that probability was 0.5. But what is the probability that the bolt we choose happens to be exactly 15 centimeters long? Well, it may come a little bit as a surprise, but that probability is 0. Okay? And you might think like, but why in the world would that be? Like, surely there's a bolt out there that's 15 centimeters long. Well, yes, perhaps. However, because there are an infinite number of possibilities, okay, when there are an infinite number of possibilities, the probability that x, the length of a bolt, is equal to any particular value is, practically speaking, 0. Okay, that's because that 15 centimeter long bolt might actually be 15.00000001 centimeters. Okay, it might be 14.99999. While we would call it a 15 centimeter bolt, and that would probably be just fine, the likelihood that you find that exact specific value to all levels of accuracy, I mean, think 10, 20, 30 decimal places of accuracy, is for all intents and purposes 0. Okay, so when it comes to continuous probability distributions, the likelihood you get any one in particular value will always be 0. Okay, now moving on to question F. What happens to the curve if the factory improves their processes for this bolt, the manufacturing processes, and the population standard deviation is reduced to 0.3 of a centimeter? Overlay the new normal curve to the curve in part A. So I've redrawn it here. You are welcome to just flip back to part A in the previous question if you would like to. Okay, so how does our new normal curve compare? So our new one is going to be normally distributed with a mean of 15 and a standard deviation of 0.3. So that means, if we're going to blow this up here just a little bit, 0.3, so now, all right, there's my 3 standard deviations. This one here, that's 15.3 centimeters. That next one is 15.6 centimeters. And that guy right there is 15.9. Going the other way, this would be 14.7, 14.4, and 14.1. That means that the vast majority of these bolts are now going to fall in that range. Okay, so what happens is this curve gets way higher. So it's starting to look like anything COVID related to you. Anyway, that curve gets way higher. So in other words, we have the same number of bolts being made, but because we are cramming together the vast majority of their lengths, they kind of make like a higher and higher and higher pile. Okay, that's the way that that's going to work. So how does the new curve compare? It gets much taller and it gets much skinnier, but the same area is under both of those. I know it doesn't look like that in my drawing, just go with it. All right. Okay, for part G. Now suppose that the mean is 15 and the standard deviation is 0.3 of a centimeter. Draw the normal curve and shade the area corresponding to the probability that a bolt is between 14.8 and 15.1 centimeters long. So now what I'm going to do is I'm going to take that same curve, the one in purple there, I'm going to draw that out a little longer so that we can see it better. And all we have to do to make that happen is scale a little differently. So here's my 15, 15.3, 15.6, 15.9, moving a standard deviation up, 14.7, 14.4, 14.1, going a standard deviation down everywhere to the left. And I want a bolt between 14.8, so let's call that about right here. and 15.1 centimeters. That's about right there. And if I grab the highlighter and fill this in, here's the shading of the area part that is happening. Okay, so there's the normal curve, and I shaded the area corresponding to the probability that a bolt is between those two lengths. Okay, and here is one of the, let me turn on the pen and not the highlighter. Here is one of the most important concepts for this entire unit. Okay, the area represents the probability a bolt is between 14.8 and 15.1 centimeters. Okay, area equals probability. Area equals probability. Okay, keep that in mind as we move on to the next example, which will come in the next video.